Next up, we have Garrett Smith from CloudBees. You might also know him from his open source E2 project or the MongoDB as web scale video. Thanks, Garrett.
Thank you, Bob. So these conferences work this way. There's a call for proposals. They send it out, and you fill it in, and you submit it. They look at it, and they approve it, or they don't approve it. And if you get accepted, you're like, oh, I'm going to this conference, I'm going to speak. And then you forget about it completely. Months down the road, you're like, I've got to go to this conference. So you book your flight and your hotel, and then you check the website to see what you proposed months earlier. And apparently, this is what I get. So thank you very much for coming. I got a vote of confidence just before I came in from my friend Loic, who's like, I have absolutely no interest in this topic, but I'm interested to see if you can pull it off. So here we go. Yeah, I mean, I'll be very honest with you. I think this is more of a reflection of a pathology that I have than anything else. For some reason, I am extremely interested in the general topic of code craftsmanship. And it may just be sort of like an insecurity I have with myself. I have to, like, something that I make has to be perfect, and I'm obsessed over every little detail. And of course, then I want to make other people obsess over that, and it's just not functional. So I thought about, so I'm going to talk about code beauty as a metaphysical aesthetic to folks going to an Erlang conference where there's, running Erlang on Neutrino, or, running, embedding Erlang in a supercomputing cluster, and all sorts of really interesting technical topics. So now I have the challenge of talking about something completely non-technical, more process-oriented at best, but has this horrible tendency to devolve into like personal opinions, and I like the shade of green better than the shade of blue, and so how do I make this specific? How do I make this even valuable to an audience as sophisticated as this? So thankfully, just by pure fortune, a thread came up on the Erlang discussion list just a few weeks ago, and Joe Armstrong, God bless his soul, gave me my outline. Here it is. So the topic was, do I use case statements or functions? And of course, being Mr. Opinionated, ears perk up when this topic came up. I'm typing and typing and typing this long diatribe about what I think is right. And Joe fortunately weighed in with his meaningful slice, and it was right on the money. And it really actually helped me to understand why this is an important topic. This is his point of view, so let me walk you through this. These are essentially cumulative or additive steps. So I summarized it so that it would fit on the slide, but it's basically this and this and this and this, etc. So let me walk you through it. It starts with code that appears to work. And that, as practitioners, is sort of what we all do. That's like 99% of our work. We want the stupid thing to work. That is great. You get the thing to work, you're pretty much done. If you observe it working with your eyeballs, that's pretty good. If you get it, working within a REPL, that's pretty good. If you can get it to like replicate in tests, that's even better. So you're basically observing it working as expected. So it appears to work. So that's what we do. So Joe says, look, that's great. It's easy to do that. In fact, it's actually probably not that easy. It can be challenging. Well, let's assume it's easy. To get it correct is far more difficult. So correct, that's his term. I'm not exactly sure what correct is. We can debate what correct is. I'm going to probably spin that a little bit down the road to something a bit more specific, but we'll just say it's gone from apparently working to now it is correct. That's really hard. Now we're going to go to correct, so it's a good program. It looks like it's good, and it is a good program, to now it can be easily understood by other people. So somebody else comes by and takes a look at it and says, hey, I get it. Right? So now we've expanded past the mechanical operation of software into the realm of collaboration. We're being social animals, and we're sharing. And it's like, okay, there's just not just me, but other people understand this and acknowledge this is good and correct. To be able to change that is even further more difficult, even increasingly difficult. So it's like I understand it, but then to be able to modify it sensibly as a result of finding a bug or adding a feature, that is even more difficult. And then finally, the very, very difficult, to get all of this plus make it efficient is off the charts hard. So I think he snuck the efficient in there because efficient tends to kind of sneak up toward the top of the food chain. And I think by listing it this way, he's implying that, at least from his point of view, and I would tend to agree with this, that energy should, with sort of no other information, no other given requirements of performance requirements, moving from the mechanical operation of software into the realm of collaboration and change and evolution is a very, very important part of software development. So with that, I want to take actual Erlang code and sort of apply it to this model. We say, it works, great, fine. What now? And Kent Beck, fortunately as well, not more than I think 4 days ago, tweeted this. Now I don't know if these are his actual words or if he's quoting somebody because they were in quotes and they're kind of messy. And it took me a while to figure out what he was talking about, and they're in 2 separate tweets, but let me tell you what he's talking about. They're also swapped in order for some reason. So he says, if it doesn't even work, there's no time for scruples. Right, so don't talk to me about correctness or modifiability or grokkability or efficiency if the thing doesn't work to begin with. Those are the scruples. Those are the higher aspiring goals that we have as software engineers. So those scruples. If it doesn't work, it doesn't matter, right? Those scruples. Now it works. Now it's time for scruples. So this is kind of the basis of what I'm going to talk about. There's a thread of aspiring to be excellent software developers. But there's also a practical element that says, as software engineers, as programmers, our job is just to get it to work. Adding all of these other features on top of that is beneficial. It can be incredibly beneficial, but it's a progression. It doesn't have to be either or. It's not a religious thing where you're either a terrible, evil, damned soul or a heavenly, angelic soul who is writing beautiful code. So it's not one of these dichotomies. It's much more of a gradation. All right, so you probably have in your courses run into the Whopper, some code that either you've written or someone else has written that is just absolutely fantastically awesome. So this is just 1/3 of it. That's the other part. And that's the other. That's one function. So we have one function that spans. Now this is Erlang, so you're all laughing, but this is very common in C land. Or many imperative languages. So this actually isn't all that long for a single function, but in Erlang land, it's pretty extraordinary, and you actually have to look pretty hard. I didn't do an exhaustive search across. It'd be very interesting to do a study across GitHub to see what the statistics are. Probably somebody's done that. But I will tell you, and I do name names in this talk. I'm not afraid of that. And I'll tell you why I name names. I'm not afraid to name names because I've written this stuff before. You've probably written this stuff before, and frankly, it doesn't matter. There's no shame in writing this kind of function. This comes from CouchDB. If you want examples of really, really horrible Erlang code, CouchDB, I'm going on the record saying this, CouchDB is second only to core Erlang. Core Erlang is by far the most horrific. It's so easy to find terrible code in OTP source. But that's sort of the point. It's like this code has worked wonderfully for years and no one gives it a second thought, right? And so here's some jackass coming by and saying, you've written terrible code. That's absolutely nonsense. There are things that we can do better. There are things that we can craft and hone, and we'll take a look at the specifics of that. But really, again, at the end of the day, just get the thing to work. So my theory is this, though. So we'll talk about scruples. So Kent Beck talks about scruples as scruples as if it's a cost. So it's in advance. So you have something that works. Now I'm going to spend the energy to have scruples. But what if we could have it work and have all of the goodness for basically the same price? It's the same cost. So in other words, to do the right thing, if you have an option of A, the terrible code, or B, decent code, or C, awesome code, and it really doesn't cost you much more to do C, why not just do C all the time? So I think really, so the benefit of that obviously is more than it works. It's when I come back to it, I understand it. So it's, I can understand it. It will anticipate if it's quote unquote correct code. you will probably have fewer or no bugs. And if others can contribute to it, you now extend your ability to mutate and evolve the software to meet other needs. So really, it's a huge lever. So I think this is not just a matter of aesthetics or opinion or feel good, pride of work of craftsmanship. It is all that, but it's practical as well. Okay, so that's the Whopper. And what I did is I looked at the Whopper and I said, what are sort of some of the elements here that we might want to think about possibly changing? And so it kind of breaks down like this. So in this talk, we will cover, I hope to get through most of this without boring everybody to tears, function names, argument variables, function scoping, and types. Basically, the first 4 there are kind of tied into the same thing. The weapon of choice in Erlang is the function. There's not much else. You don't have class abstractions or other structural, data structure-oriented abstractions. It's pretty much just functions. So if you want to kind of improve, you want to think about functions. You want to think about all of these things, and we'll get into that. And then case and if, and I've got some miscellaneous things and comments here. Case and if actually turns out are also tightly tied to the ideas or the problems associated with functions. So we'll see this is going to be a lot about functions. Okay, so let's transition from the world of metaphysics and philosophy, which is just so gripping and compelling to the Erlang community, into something specific. When I say specific, I mean like naming convention specific, really boring things. Okay, so you don't see this very often, but like lower camel case conventions just don't ever do that. Probably never, no one ever does. But if you see it, it's out of place. And this is better. The underscore convention is the standard in Erlang. I find that, and I did this. Well, actually I didn't. When I came into Erlang, I kind of made a point of studying the canonical forms just to make sure that I didn't just sort of randomly name things. So there's a number of standard function names that you tend to run into. Set element, add element, store element, put, the things that write into structures, those are not standard. Those seem to be like deliberately non-standard. I think every action, every put verb in the English language is used someplace in Erlang core. So there are certainly things that fall outside of this, but these are fairly standard. Well, there's exceptions to new. New is typically used when you create a new structure, a record, some type of data structure. So dict new. Start and start link. You should never change those. You should never, if they all have very specific meaning, always use those. And init, handle is a convention, handle message, handle info, handle cast, I'm flipping into E2. Handle cast, handle call, handle info, handle something is a very typical pattern to see. So if you will see some prototypes, some function prototypes, that if you find yourself writing one of these functions, name it handle underscore something. So the more you, if you're a seasoned Erlang developer, you know this, so it's kind of silly to even talk about it. And if you're not, just pay attention to the OTP. I think OTP core is quite consistent on these lines. Just pay attention to it. Pay attention to the types of functions and how they're named. Don't worry about getting it all right. Just code however the heck you want to. But then when you discover, oh, this is standard in Erlang, and I've been not doing it that way, just see how long it takes to fix it. And now all of a sudden your code is now somebody who's not you can look at it and say, oh, I know what you're doing there. So that's the advantage of being on the same page. This is kind of common sense block and tackle, but it's shocking to see how rarely it's followed. There's just a lot of new projects, a lot of folks come in and just they don't seem to, probably rightfully they don't care, that's fine. I'm not saying they should care, but it is just one more barrier to collaboration with other developers, and the grokkability factor starts to go down. And I might even argue that the code quality in general of those libraries tends to be consistently lower, but whatever, I'm just being kind of a jerk there. All right, argument names and variable names.
Garrett.
You know, I skipped something. Yeah.
I was just going to ask the underscore ACC.
Yeah, I like cut off that slide in mid slide there. Yeah. So the last two are. So the last one is actually not that canonical. It tends to be a pattern that's used. So that's accumulator. It's an accumulator pattern. And we'll see an example of that type of function later on. That is extremely controversial. Probably shouldn't even be up there. It's not, to call it canonical is quite a stretch. To put it in the same league as StartLink is extraordinarily stupid of me. So anyway, I should have an asterisk next to that, or I should just delete it. Okay, so this is what I do. I do this all the time. When I'm naming a function, apart from these things which are standard, that's easy. The difficulty comes in when you have a function. I think probably the most important effort that you can spend in improving your Erlang is to pick good function names. It's remarkable how little you know until you've actually picked the right name. That process, I find at least, is an extremely healthy and difficult process. It forces you to just put a name on something that is working. Like you can see it working, it's fine, but to name it correctly forces you to understand the problem. It's one step into understanding that problem more clearly. If you can't find a good name for it, ask yourself why. Why is it so hard for me to name this thing? Chances are it's either a very strange function that does a very strange thing, and those exist, so there's just some functions that are hard to name. Or you may simply not understand what it's doing, why it's working, why it appears to work. It actually may be incorrect, but appears to work. So this is the first step to kind of getting your brain into that space. A lot of times what I'll do is, if I get into a function where I just don't know what the function, I can see it working, but I don't know what to call it. I don't know what it's actually doing. I will call it blah, 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 under XXX, literally, and I will call it. I'll just make up some crazy name, and I will call it, and I will look at it, and be like, okay, now what do I name it? So I get it working first. Once it's working, I have a model. Like, I know this is doing what it should probably be doing. Now what is it doing? And then I'll rename it, hopefully well. But this was also recently, I think it was, this was more related to the number of characters you tend to use in argument variable, or arguments to these things, the functions. I'll talk about that next. And I think there seemed to be a tendency to want a rule, like here's the rule. For me, the rule is just common sense. If it's either clear or isn't clear, and it usually comes down to sometimes things are unambiguously better, but a lot of times they're simply a matter of opinion. That's fine. At least think about it. So I think that process is it's getting it to work plus. It's moving down that road. And yes, it takes time, and yes, it takes time away from drinking beer or writing tests or whatever other things, or drinking beer and writing tests at the same time. All that stuff is like eaten into by this. But what I found is if you do this more and more and exercise it, you just go faster. And so pretty soon it becomes, do I pick option A, which is not very good but fast, or option B, which is really good but slow? If that difference is little, right? If B is just about the same as A, just go with B. It's simple. You'll never get the B though unless you start down this road. Okay. So argument names and variable names. Obviously, in Erlang, you have to start with a capital, so you're forced into that. And I haven't really seen like an upper camel case underscore convention by anybody who's not totally psychotic. So that's probably a moot point there. I would just say, yeah, this is getting to like philosopher talk, short but not too short. Oh, whatever. That sounds horrible, but it's not bad. Just don't be. I've seen variable names that are extremely long and verbose, it's almost like a sentence, and the developers tend to take pride in that and think that that's a feature. That's an advantage, and maybe it isn't for me. I like if the scoping of a function is limited enough. Arguments tend to be fairly unambiguous. You get into problems when you have like scope creep in your functions, and you have functions where you have similar variables, and you'll have extremely bizarre, terrible names like arg. We'll see some examples of the choice that people have for these. Oh, here, just go back to this. I'll pick on couch. Love it. I mean, look at that. Handle changes. I mean, might as well say do something. Just call it do something. Do underscore something. Args 1. Right, so I'm like, okay, well, that must be something that changes, because you tend to see a suffix of a number when I would expect to see iterations of that, like at args 2. So I'm like, okay, well, he's starting with 1. Usually you start with 0, but in this case it's starting with 1. But then it's got a db0. So now I'm just completely confused. And then a rec, which I assume is request. Right? So that is just unambiguously, to me, bad. And it could stand improvement. But if you look at this function and you start to change that, you say, well, in fact, I think I did start to refactor one of these. I'm just like, this is intractable. Like, if I start to modify this thing, it's going to fall apart. And if there's a bug in this, it's going to be very hard. It might be easy for somebody. I'll just say it would probably be hard for me to sort through this soup. And it's really not that hard to go from the Whopper to something not quite so Whopper-ish. So just by naming things, you get there. And by keeping things smaller, your scope smaller, here we go, it's much easier to name variables. If you have an incrementer, for example, that just adds something to a number, you don't have to say number, right? It's just one simple variable. Just say n or x. So that's like a very prototypical example of a very small, focused, clear function. You don't have to get caught up in elaborate variable names. So these design patterns or principles kind of help each other out as you use them. So again, common sense prevail. I'm not a big fan of what's the Microsoft Hungarian? Yeah, I'm not a big fan of that, even in the languages it was meant to be used in. Certainly not in Erlang. If you have, I don't know why you'd ever do that, but I see this quite a bit. So, yeah, so, user list. Users is unambiguous. It's users, plural. It's more than one. There's only one list type in Erlang. So there's one pattern, and this gets into sort of, yeah.
With regard to one list type, what about like collections? Like say you had a dictionary of users. Would you call that a user map, or would you call that users as well?
Yeah, that's a great question. So it would, to me, so let common sense prevail. This is like total BS response. So here's how I would approach that. If there's really no point to calling a map in the context of the function, if there's no value of that, then I wouldn't. But a lot of times in a case like that, the map will be a map. It's important to call it a map because it's used as a map. So it's not just a list. In fact, it isn't a list. It is. So in that case, I will probably call it user map, because it's more of a map in that case than it is some congregation of users. But let's say I have a set of users versus a list of users. Would I call it a set? Yeah, I do sometimes call it a set because the API that you're interacting with is differently, so it helps to clarify it. But maybe you look at it and say, users makes sense there, or users list, or you look at your stopwatch and you're just like, I'm spending way too much time fixating on this particular point. Now I do that, but I'm messed up. I really am. I've like, what should I call it? Should I? And it's not. I know that I'm wasting time. I know that this is not a productive. But it's like, when you go to bed and read a book, it's probably a waste of time too. But it's enjoyable. It's edifying. It is. Should I call it a map or not? That's like, like what is this thing? And just grapple with these massive issues of the universe. And eventually you get faster at that, or you develop your own patterns, or if you're working with other people and you see a convention, you're like, oh, I like this better, and you adopt that, and off you go. Yeah.
I was curious if you think using spec is another way to kind of tag things. Like if you say in the spec that it's a dict, you just call it user's name.
So I don't. My personal, this is completely me. My approach is I like the code to speak completely on its own. Spec would be used for a validator or for documentation or for something else, but it doesn't help to clarify the code. In fact, I'll make that point a little bit down the road, but yeah, in general, comments, even a comment is a flag that there's something ambiguous and odd about something. So I tend to, as a point, not make comments, but instead refactor to make it clearer. But whatever. It's really the baseline is each person is just approaches it with wherever they are at that point in time. It's much more important to be on the road to improvement, whatever that improvement looks like. you know, I think the net value to the universe of, you know, whether something is suffixed with map or not is minimal. But if it helps to clarify something, if it helps to save CPU cycles when you're reading, brain cycles when you're reading a function, by putting 3 more letters, just do that. It's fine. And you don't know until you've seen it over time. I mean, I've been sort of on this exercise for a little bit over a year now, and I'm still changing things around. I mean, it's just like a crash course on trying to figure out what is best here. And I think if everyone did that over the course of a year, everything some things would converge into sort of a best practices pool, but everyone would have a set of things that are different for each person. Okay, so this is a pattern of, this is the GetOpt pattern, and it's used quite a bit in Erlang. It's a little bit more modern version. Because arity is the only way to differentiate functions, you don't have overloads based on type, you can run into collisions very easily. So if you have functions that have lots of arguments, it's generally a bad idea. And I shouldn't say it's a bad idea. It can cause problems in a number of different ways. One way to fix that is to adopt this pattern, which is for every function, you create a bare minimum requirement. So if it can be done with no arguments, then you have a variant that does it with none. If you can assume logical default values. And then you gradually build up a set of optional required, well, because arity, you can keep adding new functions. I'll show you in a second. Up to a certain point. So you have a minimum number of required arguments, and then you have a single options last argument, which contains whatever else you want. So it's similar to a command line interface where you have a minimum set of required parameters, arguments, and then options, which are dash dash whatever. That's GetOpt. So that's its convention. So here's an example of that. So this is real code. This actually isn't a very good example, but my goodness, it's very time-consuming to find these good examples. I do apologize. I was lazy here. I just didn't have the time to find the perfect example, but this is an okay example. So replicate master. There are 3 official required. I can't replicate a master. This is a MySQL replication command. So we manage MySQL servers as one of our services, so we will set the replication up for you on the back end. So I need master, I need file name, I need position. Impossible to do it otherwise. So that's the bare minimum. And then I've got another thing here, which is there's a check, there's a validation. It's interesting. As I was looking at this, I realized this is actually kind of a badly conceived function, and you can even see if whatever you can look at afterward. Don't worry about it now. But once I started to immerse myself, I started to think about what am I doing here, and that got me into the domain space, which is really where I want my code. So it's not that big. It's only a few lines, so I could read it. But clearly, when I wrote this, I just didn't really think this through very well. But anyway, it's a good example of the use of options. That's even though it's a bad function. So in this case, there's a don't check flag. If it's true, then it takes a different path. So that's a very, very, I think, an extremely elegant pattern in Erlang that works very well because of the arity restriction. You don't have type function overloads. Okay. So I'm going to just punch. This is it. Boom. It comes out. Function scoping. Like this to me is it. Like it comes down to Erlang functions. I'm not talking about a metaphysical abstraction and some philosophy. I'm talking about naming an Erlang function, and in particular, what does that function do? Because once you understand what it does, it becomes much easier to name it. So it does come down to scoping. What does this thing do? To stress it again, I think it is very, very fair that this be an iterative process. I find it difficult to write the correct version initially. I have to get it to work. I have to see it working. And then I have to get my head around what is going on after I see it working. So iterative, get it working, then improve. It's very difficult to write functions that do more than one thing. This happens all the time. It's all over my code, all over the example. And you just throw a dart to the wall, you're going to find functions that do multiple things that should be simply split into 2 different functions or multiple functions just based on that alone. So it's very simple to say, what is this thing doing? Describe it to, this is another Joe Armstrongism, which surfaced recently. Well, I think actually this one came out a while ago, but he mentioned it again. Apparently, Joe Armstrong has a rubber duck. I don't know if this is real or not, but let's just pretend it is because it's a great story. So he has a rubber duck on his desk, and he explains to the rubber duck what the function does. And if he can't explain it to the rubber duck, then he needs to go do work. So what this simply is a matter of taking an abstract concept and turning it into concrete language, which English language, whatever your language is. Explain it to the duck. That is can be very difficult to do. When it's difficult to do, it's a sign that you've got some work. Understand what that thing is doing. What are you creating? Why are you sitting in the desk in the first place? Why are you typing into it? Like, why am I here? That becomes existential, right? So when you're talking to this duck trying to explain what this function does, and if you can't, it becomes a crisis for you. And then you start to talk to your therapist. That's when it becomes, or the duck starts talking back. The duck starts talking back saying, what do you mean by that? Or do you really need to do that? Or that doesn't make any sense to me. So the dialogue with the rubber duck is important. And to me, this really is work. I mean, it was shocking for me personally to see this emerge as I started to kind of go down this road, that I would land into, I would just go, it's like a vice. I'm just like, boom, I don't understand this problem. And the reason I'm having a hard time writing this focused, well-named function is because I just don't understand what I'm doing. Now, if I understand what I'm doing, and I work on that, and I solve that, naming the function and the function scope becomes completely trivial. It falls into place, boom, like Tetris. So that's it. If it was one slide that you could just photograph, don't photograph it, because it would be this, though. All right, so what do we have here? 20 minutes. Oh, we're going to do this. We're going to get this thing done. The question is, will you survive it? 20 more minutes of because this is going to be like code stuff. Oh, this is interesting. This is fun. So these are there's probably some prototypes that I've left out, but these are kind of like prototypes. They used to call them types, but it's really more of a prototype. I don't know what it is. It's a descriptor of the type of function. So we'll go through each of these, but the purpose of this exercise, like just thinking about it, is I find it very helpful to recognize when I'm writing a particular type of function. I say, oh, I'm writing this type of function. Number one, if I can't identify the type of function, that's a sign. And again, there's probably something I've left off here. But if I have never seen a particular pattern before, if I don't know the patterns in the first place, it's hard to recognize something that doesn't fit. Recognizing something that fits is one of those triggers. Like, what is going on here? Why am I doing this? Is there a more direct or canonical or standard approach to handling this in Erlang? These functions kind of serve as a basis for that. So let's walk through them. Okay, dispatch. This is really, really common. You'll see a function that simply takes an argument, does a pattern match on it, and delegates it out to another function. It's very, very common. It'd be fascinating to do studies on to see how this breaks out in actual GitHub. GitHub is just like this gold mine of information, but to see what percentage of Erlang functions actually come into this category. But what a dispatch does is it's just an application of logic. It's a transformation. It says it's a gate. It says I'm going to get an input, and I'm going to direct it out over here based on its type. And it's remarkable how much effective work can be done by chaining these gates together. It's just a bunch of functions all lined up. And if you look at your code and code of others, you'll spot this all over the place. And the dispatch should simply look like pattern match, call, pattern match, call. It's not doing anything other than that. So handle message, I should have done handle info there. That's I'm cheating with E2 because everything's called handle everything is under handle message, but handle info is an example of that. Handle cast, handle call. That's in Gen server. That ping in this case. So that's the ping is the front end. It's the client-facing function to a Gen server call to this server. So it's a dispatch. Very simple. So this is similar to a dispatch, kind of, it looks similar, but it doesn't actually dispatch to anything. It's just a translation. What you're doing is taking state from one that's intended for use in one context, and you're translating it into something for another context. So in this case, we're talking about this example. It's param to action. what it's doing is it's taking an HTTP parameter, and which could be anything. It could be like whatever the web developer wants. So whatever's submitted over the form, which is a string in this case, and it's converting it into something that the program in this case wants. So it's a little translator. And this is actually fairly common. You might be taking a reply. Oh, a great example would be dict find, which returns OK, comma, value or error. Maybe you want to translate that into undefined value or some other thing, or maybe you want to raise it. You'd use fetch if you want an exception, but you get the idea that some API is out here that I didn't control, and I don't want to deal with that interface. It's not my interface. I want my own interface. So you create translators that will do what you want, and so that's. Yeah, you'll see these examples that I have sort of for the functional model and the case example. So keep an eye on this. I don't think I have time to point that out ad nauseum, but you'll find that case and function are kind of like doppelgangers. They can kind of go back. Those are the same thing. It turns out that they often compile down into the same code. They can be used to do the same thing. They can be used to describe the same thing. And which one you pick is often a matter of just what is clearer, and it's very subjective. In some cases, it's not one way is better than the other. But the use of case and the use of functions can be interchangeable in a lot of cases. So I have them top and bottom. You'll see alternatives to as we go here. So this one you see not so often, but in a functional world where you don't have to try to avoid if or case expressions. But let's say there was a time when, I believe, when Erlang didn't have case expressions, or certainly if expressions. So you'd have to handle conditional logic this way. It's a type of dispatch, but it's a dispatch on typically a single argument variable. In this case, we have delete expired user. So I want to know if you typically would say if down here, you'd say case user expired true, then delete. So I think that's very clear. I would probably opt for the case form in this case, personal opinion. But you will often see a maybe form out there, and that's typically when you're doing a bit more. There's a bit more to process in the condition, or maybe you're pattern matching, and the pattern matching just syntactically it's not very clear, or maybe you want to put a documentation on you want to formally represent this translation, this conditional logic as a function, so that you can test it. So putting it up into the functional layer gives you that advantage, completely independent of readability. Result handler, very common. So rather than handling a result in a function, so result, assignment result equals, and then handle it, you just pass it on to another function. So it's like a pipeline. So you do something with one function, you handle the result with another. In a lot of cases, it makes sense to use case. But in a lot of other cases, handlers are, the variation of what you can handle just makes more sense for a function. And it can also be tested, and it can also be documented. Accumulators, so that was that under ACC, that standard canonical form that you see all over the place. You actually don't see it all over the place, so I'll officially remove that later. But there's a lot of alternatives to doing this. You have higher order functions in the list module. You've got, in this case, list comprehension works well because it's a comprehension over the user's list. But accumulator is you basically, so the front end here is format users. That's what you would typically, it's very simple, format users. You don't pass in an empty list. That's a crazy interface. But the implementation of that calls the under ACK, which is an accumulator. That gets an initial empty list. And now I'm going to pull the head off of that list, format the user, and push the head back onto the accumulation, and then reverse it at the end. That's a very, 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 very common pattern. There's alternatives to it, but this is such an easy pattern to write, I tend to use it quite a bit. But just recognize it. If you don't recognize it instantly, you ought to, because start getting used to it, because it's so common in Erlang. And then the flip side of that is the list process. I should have switched the order of these, but this is simple. We're just going to process. We're going to pull the head off the list and do something with it until it's empty. Very simple. There's a for each function, which is a higher order function of the list module, which you can pass along a function to, which arguably makes that clearer. So which one do you want to use? I would probably use the second one in this case, but in a lot of cases that print users, that second, that could fill out quite a bit, and you'd have a second function here. So this starts to look bigger. Again, bottom line, this is the ingredients to the soup. You make the soup, taste it. Does it taste good? Good. Keep doing that. If it tastes bad, reject it. But at least now we kind of can sort of think about the types, these prototypes. All right, 2 more here. Yeah, we're good. We're good. So these are a little bit more esoteric. This one, and I'm starting to use this a little bit more. I've used it for a bit, but I thought I'd highlight it because I think it's a very useful pattern. Probably end up using it more, but it's basically whenever you see a function that is doing a bunch of different things, it's a candidate for this type of pattern. If you say do this and then do this, it could all be function delegation. Right? Every line could be a call to a function, but what that might be is more of a workflow type of function when you want to do a whole bunch of things and then are chained together. At a certain point, you might want to put it into this if you want conditional logic to be applied in between those phases. Because putting if statements inside of that, you end up with this horrifyingly nested and very difficult to read. I should put an example up for that clump of Erlang code. You can get rid of all of that and make things very elegant, I think, using this pattern. Basically, you load up your operations in a list. And these can be represented as atoms, or you could just put the functions directly in them. So those start, init, verify, notify, those could be the functions directly. And you pass that into an apply, something that will go and take the item, the phase, and make it so, and then handle the result. So in this case, we're handling the result. If it's okay, we just keep going. So we move on. If we get an error, now we handle the error. So we have effectively implemented if sort of what you would see very naturally in an imperative language, because you can have conveniently return out of the middle of the function. You don't have to nest. You can have if statements. So it's difficult and messy to do that. And when you start to do that in Erlang, your code starts to look like hell. It really does. I'm going to skip state and it's trivial. Let me jump ahead to a point real quick here. And this is the imperative trap. This is what I call the imperative trap, because it's very dramatic. I would say that most of the pathologies in Erlang code, the really, really bad things, I mean, just things that shouldn't be, are a result of somebody taking some imperative code and translating it, or taking their imperative worldview and applying it directly without any thought, because you have an if expression. And it seems like it might be useful for this type of, this is a disaster. So it took me a while to look at this and even figure out what was going on. It's just so odd looking in Erlang. So what he's doing is I suspect, this is from early DTL. This is not Evan Miller's code to my knowledge. Evan's not here, so I can make fun of him. But what I'm hoping this is a design, is like a translation decision to go from Python or something, so that they can kind of keep it in sync, because it's really non-standard. This is this is how you do that. You don't want to take your literal code from Python or Ruby or whatever and try to copy it and make it fit into Erlang. So knowing that you implement conditional logic, either using a function, pattern match, or a case expression, will help to avoid that. So you're not having to bind. There's lower bound is an unnecessary bind there. And it just clutters it, and I was confused when I saw it. Now imagine this type of pattern in a function that long. When you're just I was trying to come up with some refactoring examples, and I ran into a few, and I started down that road to refactor. I'm just I would never want it to refactor. It's too time consuming. It's just, I have no idea what's going on here. That's bad, because that's bug hits that code and you're afraid to change it because you have no clue what's going on. The good news in Erlang is there's no reason for that to ever be the case. You don't have to have that sort of code. So just avoid this imperative trap by not doing it. Just avoid it. Don't do it. Here's another example. I looked at this, I'm like, surely there's something clever going on here that I'm not seeing. But it's again a case of somebody trying to make it look like, and this is not a criticism. It's a bit of a criticism, but it's not a terrible criticism. Again, it's just like, fix it here. So this was easy to fix. That's what this looks like. So what's going on here? So parsing this, and it took me probably a good 60 seconds of just going, what on earth is going on here? But I started with this and said, okay, well, I don't care what that is. I know what the result is. Fortunately, this is a side effect free function. I don't have to guess at things. That's what the return value is. Then I just reverse engineer that. So what he's doing is returning a tuple of 3 elements. And from my point, those want to be generated by 3 functions because they're 3 separate logical functions. And now you've got this nice syntax in Erlang, which is very, very compact and readable. Default start, if it is past I don't know what that empty list would be. That's a little strange. N might be I don't know why. I don't know what that is. So that variable should be renamed to something clearer. Something should be fixed here. I don't know what's going on, but the code is at least, a world better than it was before. But that's an example, though, of once you. Yeah, I don't know if you were starting and you just said that looks perfectly fine, but if you're going to criticize Erlang for looking like hell and that looks like hell, don't do that, and then it won't look like hell. So if you're tempted to write really, really horrifyingly bad code, what I would do. Here's what I would do: send a note to the list. Do not be afraid or timid, and just send it out, because it's literally, if that works, ship it. Fine. Don't worry about scruples. Just get it out the door. But it's so much faster for me to write something like this than it was that. So just do that. If you get to the point where you can do that, why not? Yeah.
So in this case, that's a huge improvement. But is there a point past which you make matters worse by, instead of having a proliferation of lines within one function, you have too many functions to be able to reason about?
Yeah. I mean, if you want to minimize the number of functions, you're going to hate everything I'm talking about. You're just going to be like, this is horrible. No, there's an explosion of functions. It's not even, it's a good order of magnitude more. I would argue that's a good thing. The functions are clarifying devices in this language. This is an extremely simple, straightforward language. You pick a name of a function, its arguments, to go into the thing and something comes out. That little machine that you create, if you can tag that and reason about it and understand it, it doesn't matter if there's 10,000 other ones. Your universe of interest is only in the one. And so it doesn't matter what level you look. That could be a highly leveraged function that calls a bunch of other functions, but it doesn't matter to you. It's like, it's like a taxonomy that has to be hierarchical versus tagging. A tag system is infinitely scalable. You can have trillions of things that are all marked. And it doesn't matter, you can mix and match them and rearrange them, and it doesn't have to be hierarchical. So I think there is a tendency to try to organize these things so that you can understand them. But if you get over that hierarchy, or having to say this is the top node and it has children's and now I can reason about each stage, just flatten it all and describe each one as it is independently. And you forget about levels and everything becomes very simple, like, default start. That's a terrible argument name. N, what is that? Why is a number being lined up with a list? Like, doesn't make any sense. Now, but I can reason about that now and improve it. And this is the extent of my universe. I don't care about anything outside of that function for that particular point in time. Okay, I have 2. Yeah.
How would you organize functions in a module? Is there a preference?
So here's what I'm doing now, and I think I'm going to stick with this because I like it. I use them in the order in which, so everything starts with the exports. So the exports go first, because that basically you're starting with, the reasoning is this. The purpose of the function is to provide exported, purpose of the module is to provide exported functions. So those go up top. And then as you invoke the functions, you define them. You don't group them together. And the reason you do that, and the reason I like that, is it makes it much easier to find the function when you're trying to read down the code. So you basically want to be able to read the code from top to bottom. So because there are so many functions, And this whole worldview is predicated on a decomposition around the functional abstraction. Searching and hunting and trying to find functions is expensive. So make that cost as cheap as possible. And I found the cheapest way to do that, apart from a fancy IDE, that would give you you have all sorts of novel views to this world. The easiest way to do it is just say, if it's used here, it goes immediately under it. And there's an unambiguous ordering to these functions. So you can say this is wrong and this is right. It doesn't come down to opinion. I used to do it, if you use the Emacs templates, you'll see there's they break it into these sections. So you have like public interface, you'll have the behavioral functions, and then you'll have the internal or the private. So lots of my old code has that stuff. I can't stand it because I have to go all over the place looking for this, that, and the other. I tend to have banners that I don't have the comments for every single function, but I'll have banners that will say like start/init. And so all of my init, if it's a process, if it's a gen server or an E2 process, they'll be in one section. Sometimes I'll have a thing at the bottom which is like general purpose. So obviously my religion is breaking down here a little bit, but that's the approach I'm taking. I want to basically minimize the amount of time it takes me to find the function I'm interested in. Okay, so I am officially out of time. Let me quickly scan. I just want to make sure that it's just a super important point that I don't miss it. But then I'll maybe just a few questions and then we can be done. We've talked about that, miscellaneous. Oh yeah, this is right. This is one thing that this is literally the one thing that I insist on. In any code that hits a repository that have anything to do with, if it isn't 79, I go ape shit. It's like this. If you can't figure this out, and the argument is like, well, TextMate, whatever, and I'm running a Mac and it doesn't, dude, the one thing I ask is the simplest thing. How it's going to be impossible to talk about all of the other stuff that we just talked about if you can't do this. This limits the amount of nesting. This is why this is important. First of all, in Emacs, you can get on this laptop, you can get 2 windows in parallel. That's why this number is important, because my laptop, Emacs. So that's number one. Number two is it limits the amount of nesting that you can reasonably do. Here's a good one. This is one of my favorites. Okay. This is the amazing NestedDo function. It's like the title of a video. I'm going to use this for a video. This is amazing. If you go into the HTTP, the inets application, I'm making fun of, we're all in the same family, so I'm making fun of, who knows who wrote that code originally. Terrible code. But it keeps going, and it's just crazy. And all these modules look like that. They're super nested. And this is so far off, I'm basically here with Emacs. If I do toggle truncate lines, or whatever, toggle truncate, it cuts it off here. So no, 79, it's the rule for everybody in this room. Yeah. So do this. I mean, if you're interested in, there's some other interesting examples in here. And if you're interested in it, maybe this evolves at some point into some other community document that we could throw patterns or whatever. Who knows? If anyone's interested, though, I'll have this certainly posted, and it'll be available, so you can kind of dive into it afterward. Any quick questions? Because we have to have tea time.
Any automated tools to enforce anything?
I'm sure there are. You'd be surprised to find that I have an opinion about that. I'm kind of feel like code craftsmanship, the thing. It's not that hard to do this. It's not that hard. And if you're doing it manually, you just get really fast at it. And I know developers who will use the code formaters, and they'll literally do this. I'm just like, you've got to be kidding me. And they'll hit Control-Shift-F, and then it just gets formatted based on their formatting engine. But then everyone has to have the same formatting engine, and just use Emacs, and then it's all the same. It's very simple. It's so simple. If I had to do pages, tabs, I would, or spaces to yeah.
Yeah, what's your opinion on
Could you repeat the question?
Yeah, sorry. So the question was the practice of including records in a module versus an includable, an HRL file. But I think it's also probably has to do with whether others can see it, right? Is that the
Yeah, sorry, I mean like having a dedicated data structure module and you can find the record in that module.
Yeah.
You can object modules,
yeah.
including HRL.
Okay, so the question is my thoughts on a data structure module. Yeah, data structure modules are very canonical. Use dict as an example. When you do dict new, it's some god awful thing. Every time I see it, I hurl, but it works. So that's a good example of just like it's an opaque data structure. Yeah, you can see what it is and pull it apart. But no, that module wraps that up. That's its territory. And you want to do that same thing. So if you're dealing with a data structure, you want a module dedicated to that. All its life cycle and mutation, all of its operations go into that one module, just like dict, just like sets, just like lists, just like all the other ones. Yeah. Okay. Thank you.